Hi children. Already you learnt about natural numbers, whole numbers, integers, rational numbers in your previous class. Let us talk about natural. Counting of numbers are called natural numbers. That means counting starts from 1, 2, 3, 4, so on. That natural number set is denoted by capital N. If we include 0 to the set of natural, it is called whole numbers. Then we include a negative to the set of whole numbers. It is called set of integers. It is denoted by Z. Positive integers, negative numbers and including 0. Now come to rational. The numbers which can be written in the form of P by Q. Q is not equal to 0. P and Q belongs to Z and P and Q coprime. Now in rational numbers, we applied now 4 conditions. The first one is P by Q form. Second one is Q is not equal to 0. Third one is P and Q are coprimes. And the fourth one is P comma Q belongs to Z. Now a new word come to the coprime. Now let us see the word coprime. Suppose we have 4 by 5. Let us consider the numerator 4 and 5. What are the factors of 4? 1 comma 2 comma 4. Now come to the factors of 5. 1 comma 5. Now what is the common factor in the two numbers? 1. That means suppose let us consider 8 by 16. Now what are the factors of 5? 1 comma 2 comma 4 comma 8. Now consider the factors of 16. 1 comma 2 comma 4 comma 8 comma 16. Now what are the common factors in these two? 1 and 2, 4 and 8. Now observe the difference between these two. Let us consider 4 by 5. For 4 and 5, only the common factor as 1. And observe 8 comma 16. These two numbers have the common factors 1, 2, 4 and 8. So now 4 and 5 having the common factor as 1. Not single factor, only 1 as the common factor. So these two numbers are called coprimes. These are not coprimes because more than 1. That means other than 1 they have the 3 factors. So these two are not coprimes. Now the fourth condition to tell a definition of rational, the first one is P by Q and the second one is Q is not equal to 0 and the next one is P comma Q belongs to Z. And the fourth condition, this is the new one to you. P comma Q are coprimes. Now, rational number. If we apply these 4 conditions, we can tell a number as rational. Now, let us see all the types of examples. Suppose if we consider 2, how it is a rational number? We write it as by 1 and come to the negative. Minus 3, it also can be written as by 1. The two are rational. Now let us come to a negative fraction and a positive fraction. See all the types, natural and whole and including 0. Now come to 1.5, 1.3 bar. See, a natural, a whole, a integer and a positive fraction, negative fraction and a decimal. How 1.5 can be written in a fraction? 15 by 10 A decimal after a number can be written as 0. Now come to the 1.3 bar. This is called terminating repeating decimal. We have a method by writing its periodicity. We can write it as a rational number. So these all types under come in rational numbers. Now come to the next one, irrational. You already know about the irrational, the numbers which cannot be written in the form of p by q. And suppose if we take root 4, what is the value of root 4? 2. This is not an irrational. Suppose consider root 2, root 3, root 5. If we do the long division, the value of root 2 is 1.414 approximately. Means non-terminating repeating decimal. Sorry, non-terminating not repeating. Suppose root 3. Consider root 3. The value of root 3 is 1.732 so on. That means non-terminating and not repeating. And see one more example for irrational. 4.56786532 and so on. That means non-terminating, not repeating. There is no repetition in an order this number. There is no repetition. These types of numbers comes under irrational, denoted by Q dash. Rational, denoted by Q. Irrational comes under, denoted by Q dash. The combination of these two, the combination of rational and irrational are known as real numbers. Real. The chapter name is real numbers. Now see a diagram here. The full box contains, let us see rational, come here natural, next whole, next integers, next rational, and separately we wrote as irrational. These all subset to one set. Natural is subset of whole, is subset of integer, subset of rational, and these and irrational. These all the subsets of real. Please observe the slide. Already we discussed about this. Let us see. Already we discussed no rational numbers and examples. They can express it as terminating decimals or repeating. All the examples I wrote already. And see irrationals. Non-terminating, not repeating. Pi is also called an irrational number. But the value of pi 22 by 7. It is a rational number because it is in the form of p by q. See root 2, pi, root 3, for example, root 5, root 7, these all.